All right, our next speaker is Blake Young. So he comes from a place called Lavernia, Texas. That's near San Antonio. Got his bachelor's at the University of A&M Kingsville, and he spent some time, well, decided to spend some time in Australia. So he went there a couple of months, worked on a farm in Western Australia, right, wheat belt, doing some planting, harvesting, and decided to come back to A&M for a master's. So in his thesis, he's looking at controlling Johnson grass, which is, by far, I would say the world's worst weed, or one of the world's worst weeds. Johnson grass. He's looking at how we can control it using integrated tools. So, like, we know we have herbicides, and of course, it's not a sustainable tool for long term. What else can we do to help manage Johnson grass, especially in the Indian sorghum, which is a transgenic herbicide tolerant crop system that will be commercialized soon. So he did a bunch of experiments over the past couple of years, looking at the efficacy of these tools to integrate with herbicides for Johnson grass. Blake, how yours?
Thanks for that introduction, Dr. Muthu. So, a little background. That picture is from Australia, harvesting a wheat field with a chaff cart, which I'll talk more about later. And my title being the Integrated Management of Johnson Grass and Grain Sorghum. So, grain sorghum was first introduced, of course, in the mid-1800s to the United States. About 1.9 million acres are planted in Texas in 2012, and it's the second most produced grain in Texas. And this picture on the right kind of shows where the sorghum producing regions are in the United States. Johnson grass, otherwise known as sorghum halopense, has been in the United States since the early to mid-1800s, when it was introduced as a forage crop. And by 1900, it was considered a noxious weed throughout the United States. This led to be the first federally funded weed. This led to the first federal funding specifically for weed control. And Johnson grass is resistant to at least one herbicide site of action in 13 states within the U.S. And acetolactate synthase inhibitor-resistant Johnson grass was reported in Texas in 2000, West Virginia in 2004, Indiana in 2005, and Kentucky in 2006. So back to the harvest weed seed control methods. Harvest weed seed control is a novel approach to target weed seed produced in late season weed escapes at the time of crop harvest. The first to kind of be developed was chaff cart. To kind of understand how harvest weed seed control works, you've got to understand how a combine works. So in a combine, there's two kind of things that will exit the combine: your straw material and your chaff material. Your chaff material being the finer material, which usually contains your weed seeds. And in a perfect system, you're capturing most of your weeds that are coming through that combine at the time of harvest. Chaff cart was actually developed in Canada for livestock operations, and they would collect that chaff and straw material into heaps and take that into their field and feed their livestock. Australians thought this was an ingenious idea to capture weeds at the time of harvest and destroy those later in season. The next to be developed was narrow windrowing, and this is the addition of a little chute at the back of the combine. When you turn your spinners off at the back of the combine, everything will just fall down the chute into a narrow windrow, and you could later go back and burn this narrow windrow or bale it, up to your call. This picture is actually a study we're conducting in College Station of a narrow windrow burning of a wheat field. It's a little harder in cereal crops, being so dry, and fire doesn't always work, so have fun, but also be cautious. The next to be developed was a direct baling system. So they integrated a direct bale right behind the combine with a chute that carried all of the straw and chaff material to the baler, and that would be later fed to livestock. These three systems kind of leave little to no nutrients left for the field, so you're kind of having to add a lot more nutrients later on. The next to be developed was a seed destructor by Ray Harrington in Western Australia. They created a chaff meal that kind of pulverized all the chaff that went through this technique, and they found up to 98% of the seeds going through this seed destructor were destroyed. And about 5 to 8 years later, they integrated that system to an attachment behind the combine. So you're no longer having to have a pull-behind method, but an integrated seed destructor that you can purchase to add to the back of your combine. Less wheels mean less mistakes, kind of a thing. And lastly, to be developed is one of the cheaper alternatives is chaff and tram lining. This picture shows chaff lining, where you would separate your straw through a straw separator, and that would be spread back out onto the field. And then the chaff would be narrow windrowed into about an 8 to 10 inch windrow behind the combine, and that just creates a very competitive environment for these weed seeds, with most of them not being able to emerge from that competitive environment. And then tram lining being the same idea, except you're following your tire marks in your combine. And that same idea, more compaction, more toxic environment for these weed seeds to grow. So the harvest weed seed control tactics have been widely tested and adopted by Australian farmers in different cropping systems. And there is growing need to expand them to other regions. The effectiveness of harvest weed seed control depends primarily on the weed seed shattering phenology and the amount of seeds captured by the harvester, as affected by the harvest height. And knowledge is very limited on the effectiveness and feasibility of harvest weed seed control for Johnson grass in the management of grain sorghum. The picture on the right I got from Iowa State, and it kind of shows where your choke points are in a weed cropping system. So in your winter, you'll have your tillage, spring pre-emergent, your post-emergent herbicides, and then enhanced crop competition and roguing. Whereas in the fall, when you harvest, you're now implementing another form of a choke point for these escapes that you missed in those other four. Basically being the more choke points you create, the more integrated weed management tactics you have, the more this technology will last for you in the future. An ALS inhibiting herbicide, Group 2 tolerant sorghum, will soon be commercially available, trademarked as Inzen. This was what Dr. Muthu was referring to earlier. And last we heard that would be commercially available in 2020. There is concern for the potential loss of Johnson grass control in Inzen sorghum due to the evolution of ALS inhibitor-resistant Johnson grass. And integrated weed management tactics throughout the crop season results in greater weed control. So our hypotheses for this study. Our first being Johnson grass retains a high proportion of its seed at the time of grain sorghum harvest, and a majority of the retained seed will be captured by the harvester. And integrating multiple weed management tactics throughout the season will effectively control Johnson grass and a continuous Inzen sorghum production system. Our objectives for this study: determine the seed shattering phenology of Johnson grass in grain sorghum at crop maturity and the proportion of weed seed targeted at commercial harvest height in sorghum. And to understand and demonstrate the values of integrated tactics for managing Johnson grass in Inzen sorghum production. Firstly, I'll go over the first objectives. So materials and methods for the study were for seed shattering phenology. The location of the study was at the Texas A&M Field Research Farm in College Station over the 2016 and 2017 growing season. We placed 4 seed collection trays, 25 centimeters by 25 centimeters, underneath Johnson grass plants, and we selected 10 plants each year. And any seeds shattered onto those trays were extracted at weekly intervals, starting at 2 weeks prior to Johnson grass seed maturity and up to 2 weeks after sorghum harvest window. And our results of the seed shattering phenology, let me set the graph up for you. On the left, you'll have cumulative seed shattering, and on the bottom is the weeks that we conducted the experiment. And the seed shattering phenology of the Johnson grass is shown for 2016 and 2017 in this graph. Week 1 indicates the beginning of Johnson grass shattering, and week 9 represents 2 weeks after a sorghum harvest window. And the main thing to really take away from this graph is that over that 9-week period, there is a very gradual seed shattering of the Johnson grass over that 9-week window, as compared to other weed species. For the field survey for seed retention, we created a survey located in the Rio Grande Valley and the coastal bend regions of Texas in 2017 and 2018. We kind of concentrated on those 2 areas for the study because they are high-producing sorghum regions, but also they have larger populations of Johnson grass as compared to the high plains. Survey sites were randomly selected using an ITN converter software, and that's noted in my pictures on the right in Google Maps. And shattering percent was estimated visually in Johnson grass in a harvest-ready sorghum field at a single time point. And from that study, we noticed about 80% of the Johnson grass seeds were retained at the time of sorghum harvest. On the left, you have the seed shattering percent, and on the bottom is the location, C being coastal bend and 17 being the year, Rio Grande Valley, 17 and 18. And that was the seed shattering percent I had noticed throughout the regions. The methods for the field survey for seed capture by the harvester. So the same field survey sites from the previous study were used, but at this time Johnson grass seed was harvested from the 1 meter squared quadrats in the 2 samples, above and below harvest height. And harvest height kind of varied between farmers' fields, so we kind of created a standard of about 30 centimeters below the sorghum seed head. Seed was collected in each portion and was then quantified. So the result here is the seed available for harvest weed seed control, and that would be the proportion of seed above the harvest site. So for coastal bend 17, about 79%, Rio Grande Valley 17, 78, and 18, 90%. Averaging all those out, we have about 82% of the seeds were present above commercial harvest height and are capable for harvest weed seed control methods. And in conclusion, for that part of my objective, high levels of seed retention and high proportion of capture by the commercial harvester indicate high feasibility for harvest weed seed control for Johnson grass and grain sorghum. And more research is imperative in optimizing harvest weed seed control methods that are attractive to and adaptable by growers of Texas. And the levels of seed retention at harvest observed here are greater than that of rigid ryegrass seed retention in Australia, where harvest weed seed control methods are heavily adopted. The tall growth nature of Johnson grass coupled with the harvest height of sorghum makes it effective for capturing the majority of the weed seed while reducing the amount of chaff to be handled. And there are opportunities for weed adaptation to harvest weed seed control, and diversified management is vital to the system. And in this picture on the right was a study conducted by Dr. Muthu and Dr. Norsworthy's group at Arkansas, and they ran material from a soybean field through a chaff mill. On the right is the unprocessed chaff, and on the left was harvest weed seed control methods after running through the mill. And you can clearly see a difference in the germination percent. For future research for this objective, testing different harvest weed seed control methods for managing Johnson grass and grain sorghum, and then improving the capture technique for seed shattering, I think could also be improved. And then possibly doing another survey for Texas in 2019, if needed, after comparing some data from Arkansas. So on to Hypothesis 2, the integrating multiple weed management tactics. An objective was to understand and demonstrate the value of integrated tactics for managing Johnson grass and grain sorghum production. Our materials and methods for this study. Locations were in College Station, Texas, and Kaiser, Arkansas. For the purpose of today, I am only presenting College Station, Texas. The years of this study were from 2016 to 2018 with a randomized complete block design with 4 applications. The system was continuous in sorghum production with plot sizes being 8 meters by 100 meters. And sites with high infestation of Johnson grass were selected. The picture on the right represents my field, and all the dark green was my Johnson grass populations prior to the initiation of the study. So we have very high infestation, especially in block 4 and block 3. And to simulate an absolute worst case scenario, we went ahead and introduced ALS resistant Johnson grass to our field. So our materials and methods treatments. The treatment 1 will be our standardized check, our dual magnum S-metolachlor-free, followed by an atrazine post at 30 centimeter tall sorghum. And this is a pretty standard practice in conventional sorghum. Treatment 2, S-metolachlor-free, followed by atrazine with the inclusion of nicosulfuron at 30 centimeter tall sorghum. This was a practice that was recommended by the Dow-DuPont Dow-DuPont industry with the production of zest in the enzyme technology. Treatment 3 was program number 2 with the inclusion of glyphosate as a desiccant prior to harvest. Treatment 4 was program number 3, but the addition of chaff removal at harvest, and that would be our harvest weed seed control methods. To simulate that, we went through and clipped our Johnson grass seed heads. I did not feel like standing behind a combine and collecting everything that went out. Treatment 5 was program number 4 with shredding and disking the field after harvest and treat the Johnson grass regrowth with clethodim. And treatment 6, program number 5, except there was no harvest weed seed control at the time of harvest. Our statistical analysis for this experiment was done in SAS using ANOVA and Proxemics, and means were separated using Fisher's protected LSD at alpha equals 0.05. And that is just a picture of one of my quadrat counts for population. The results of this experiment. This is a picture prior to desiccant application. Your picture here is treatment 1 compared to here, which has not received a desiccant application, but you're really seeing the differences in Johnson grass populations within the study. And this is another kind of overview of my experiment. All the blue arrows are your treatment 1s, and the red arrows are my treatment 2s, the standard enzyme sorghum production. Everything else in yellow received a desiccant application, and all the kind of lighter green in the field is Johnson grass. And into a table. On the left side of the graph, we have the Johnson grass population represented in by hectare. And then on the bottom is the date that the data was collected. Spring 2016 being the first year, and before any spraying, we had about 78,000 Johnson grass per hectare in all treatments. And then, as you can see with treatment 1, there is little to no grass control in the conventional practice. Being your pre was the only kind of form of grass control for this experiment. So there was no post control for emerged grasses, that being Johnson grass, that we were interested in. So as we expected, there was no differences, little to no change in the course of this experiment. Treatment 2 was where we start to notice differences. That was the inclusion of the nicosulfuron that had grass control, being Johnson grass that we were interested in. For 2 years of this study, it worked well, but in fall 18, we start to notice an increase in the population, and we're kind of attributing that to the introduced ALS-resistant Johnson grass that we added in 2016 and 2017 to each plot. So it kind of created a seed bank that carried over into the third year. For treatments 3 through 6, as expected, the incorporation of multiple weed control tactics had a greater effect than treatments 1 and 2. And this is just to kind of visualize what the table before, and I will highlight treatments 1 and 2 in those blue boxes. So you can see all the Johnson grass through that field, and there's a little less in treatment 2 in the first year of the study. But by the third year of the study, it moved into treatment 2 more predominantly. And if you forgot what my treatments look like, here they are again. And I just want to highlight programs 3, 4, 5, and 6 with the inclusion of the glyphosate. They are statistically different than that of the treatment 2 standard production in Ensign sorghum, and there is a fine line between the number of Johnson grass that's seen in treatment 3 versus treatment 2. The effects of harvest weed seed control programs 4 and 5 are not statistically different than that of programs 3 and 6. It is also interesting to note that program 3, just the inclusion of the glyphosate as a desiccant, performed as well as 4 through 6 in this experiment, in this 3-year study. So just the addition of a desiccant helped in the control of the Johnson grass from a year-to-year standpoint. Integrated weed management tactics had better control of Johnson grass than a standalone pre-post herbicide program. Glyphosate applied as desiccant prior to harvest had a similar impact as other integrated tactics in reducing the Johnson grass densities. And long-term sustainable Johnson grass control in Ensign sorghum requires the integration of these multiple tactics. And I just kind of want to leave with one note here, that when we started the study, there was no label for zest, and now that there is, they clearly state in the label that do not plant grain sorghum containing the Ensign herbicide tolerance trait in fields known to have ALS-resistant Johnson grass or shattercane. And this goes against another part of my experiment, where do not plant sorghum the year following growing of grain sorghum containing the Ensign herbicide tolerance trait in the same field. So our experiment goes against everything on the label now. For future research, continuing the study in 2019 to possibly evaluate the impact of the harvest weed seed control methods with more widespread resistance, and then determining the molecular mechanism responsible for resistance in surviving Johnson grass populations. And that we would go through and spray the nicosulfuron in our field and then test that for whether it be resistant because of gene flow technology or the introduced population that we added. And attached to references, acknowledgements, I really want to thank Mike Lovelace and Eric Kastner for providing all the seed and coordinating herbicide for me. Same with Dow DuPont Corteva, Advanced and Alta Seeds. Tammy UDAV Flight Team for providing some of the aerial imagery, and the Weed Science Group. They're awesome people. Dr. Norsworthy's research group in Arkansas for conducting the experiment in Kaiser, Arkansas. Dr. Devlin Sarangi for helping me with some statistical analysis. Dr. Neely Isaacite and Dr. Schnell for being a part of my committee. And most of all, Dr. Muthu for bringing me here to A&M and letting me do some research. And USDA and NEPA for the funding. With that, I will take any questions.
choke points were? Like, what happened to the choke points?
So the choke points, in reference to the Iowa State picture, are just an easy time to control the weeds, in a sense. So in your spring, you have the pre-emergent control, spraying your pre-emergent herbicides after planting, and an early post after 12-inch sorghum or so. Post-emergent herbicide would be another alternative for weed control, and then also cultivation. And then later in season, you have crop competition, and you would if you do have any escapes, you would have to go out there and rogue those. So you're trying to eliminate those escapes later in the season. And then the harvest weed seed control would just be that additional choke point for at the time of harvest. No worries. Yes, ma'am.
So it doesn't matter whether you do a bunch of different integrative techniques to get rid of these weeds, and all you have to do is, have glyphosate. Are there any other benefits to some of the other techniques that you studied that you want to go with them instead of just using specific?
Well, I mean, in studying weed control, there is no silver bullet, so you really do have to have that integrated approach for a long-term sustainable practice. Can you repeat the question one more time?
Yeah, so you have two years of data.
Yes, ma'am.
So let's pretend that this 2 years of data is going to be the next 5 or 10 years.
Okay.
So what would be any of the benefits for doing the other, your treatment 4 through 6 versus just applying the glyphosate? Do any of them have any additive benefits for soil health or for anything else, or would you just say, screw it, too much work to do all that, just apply glyphosate?
Well, there's definitely more intensive practices. I did not look at soil health. I kind of had a blanket treatment for most of my fertilizer applications throughout all my plots. Definitely yield is affected. Treatments 1 and 2 in 2018 were noticeably different. I did not list that here. And then, of course, weed control. I didn't notice anything else outside of those added benefits. So yes, you will be spending more money if you use more intensive practices, but I think the cost will definitely help in the later approaches in the season, as from year to year. Yeah. Brian?
How'd you get your hands on an Enzyme? It's not on the market yet.
Well, Dr. Muther, yeah, I think we're recording that, so no, Dr. Muther definitely helps with that, having his connection, but yeah, they were really wanting to kind of do a bunch of ulterior tests and just their general efficacy tests in their programs. Cynthia?
So I know the Australians use Farrington seed sorter a lot, but I don't know that I'm familiar with like the U.S. using it a whole lot. Do you know about that?
I don't know of anyone in the U.S. using it besides universities currently. Is that correct, Muzu?
So the John Deere is developing their own version, and Case AH, I think they kind of copied. There were some disputes between Deep Brewing, which is the Australian company that kind of commercialized this from the Australian farmers who originally developed it. But Case developed their own. They just went around the patent or whatever, and then I think they already have units that are ready to be sold. They're selling it around like $75,000 on top of what it's going to cost in the new machines.
Why is this a prominent practice in Australia but not here? Are there stricter herbicide regulations down under? Or?
I'd say that Australia is pretty much an early adopter in weed control. So things that are happening 10 years prior, we were just now learning about. So
Well, they've been known to follow the resistance, so they
Yeah.
run out of options. So,
They're definitely known for some of the world's worst weed problems.
so they have populations with 11 different, resistance to multiple, 11 different pesticides, so that's, it's a pretty bad problem there, so they ran out of options there.
Okay, Heather?
Yes.
So, just, you came up with your project before the label came out,
Yep.
right? So how does that affect, like, what you've done? Not at all, or?
Well, I think it would affect us in a standpoint if how many farmers actually follow the label. So, from that standpoint, that's definitely hard to answer, but
Maybe I can help him a little bit here. So basically what we're trying to do is, simulate a worst case scenario,
yeah.
even like,
Which is why you planted.
yeah, right after, like the ALS inhibitor resistance, Johnson grass and planted sorghum year after year. So, I mean, it's not a formal practice, but just do a worst case scenario and see how best the technologies do. And then you can learn from that and develop stewardship practice.
Got it.
Answer for your defense.
Perfect.
After 5, if you have any more questions, you can please feel free to talk to the speakers.